this video, I'll be showing you how to apply your cast diagram. So this is our cast diagram. So I'm going to be using very simple trig equations. For example, what do you do if you are given sine x is equal to 0,5 and they say the limit is x is between 0 and 360 degrees. So what you are first going to do, because here we are solving for x, you have to make sure that x is on one side of the equal sign. So this is how you do it. X is equal to shift sine 0,5 and then your answer will be 30 degrees. So this 30, for now, it is our reference angle and it's positive. So this tells us that the solution for x must be the quadrant where sine is positive. And then we should also look at our limit. Our limit says x is between 0 and 360. So this means we are looking at, this is the 0 degrees line. So our x can be, okay, when you go this way, 90, 180, this is 270, this is a 360. So a 360 is a circle. So this means that our x can be in any of the four quadrants. But then we are only looking for the quadrant where sine is positive. So those quadrants will be the first quadrant where all trig ratios are positive and the second quadrant where only sine is positive. What we have to do next is to apply the conditions of these quadrants. Because 30 is an acute angle and it's positive, we just put it as it is because it obviously falls in the first quadrant. So our first answer will be x is equal to 30 degrees. And then our second answer is this other quadrant where sine is positive, and the condition here is 180 minus theta. So our second solution for x is 180 minus theta, and theta is our reference angle, which is 30 degrees. This will be equal to 150. So our two solutions for this are 30 degrees and 150 degrees. And then now let's do an example where sine is equal to a negative angle. So we have, let's use the same values. Sine x is equal to negative 0,5. And let's say the limit is the same. We'll do the same thing as we did before. X is equal to shift sine 0,5. And so let's put the negative just to show you the purpose of the negative sign. So shift sine of negative 0,5 and our answer is negative 30 degrees. You see, so this negative, as you can see, it does not really change the size of the reference angle, but what it does is that it changes now the quadrants where we'll be looking for our angle. So this is how we do it. Now we are looking for the quadrant where sine is equal to a negative angle. So basically it's the quadrant where sine is negative. And our limit is 0 to 360, meaning any of the 4 quadrants. And so we come here, we look, sine is positive here, sine is positive here, but here it's negative, and even here it's negative. And we look for the conditions of these 2 quadrants. Let's find the first x. In the third quadrant, it's 180 degrees plus theta. So we're just going to say x is equal to 180 plus 30 degrees. It's important not to add the sign here because its only purpose is to show us the quadrant where we are supposed to look for x. And after that, we do not add it in our calculations. So 180 plus 30 is equal to 210 degrees. Now our second solution, where sine is negative, we'll find it here in the fourth quadrant. And the condition is 360 degrees minus theta. Remember, theta is our reference angle. So x is equal to 360 degrees minus 30 degrees. Then this will give us 330 degrees. So now what happens if the limit is changed? Let's say x now is between 0 and 270 degrees. This will show you how to use the limit and how it affects our equations, our solutions. So we're still using the same values. Sine x is equal to 0.5, and here we have the negative 1. Sine x is equal to negative 0.5. So we are going to use the same steps. X is equal to shift sine of 0.5, and our answer is going to be 30 degrees. And okay, let's start with this one and finish it, then we'll go to the next one. So it's 30 degrees in our, so first of all, let's start with the limit. First of all, we are looking for x between 0 degrees and 270 degrees. And this means we go from 0, 90, 180, and 270. X is between 0 and 270. This simply means that our x must not be greater than 180. And our 270 is here. We don't go this side. We just end here at 270. So this means we are going to look for the quadrants where sine is positive in these 3 quadrants. So where is sine positive in these 3 quadrants? It's quadrant 1 and quadrant 2 still. So our solution is going to be the same as here. We're just going to say here, since x is already an acute angle and it's positive, so it's in the first quadrant. This is our first solution. Our second solution is in the second quadrant where x is equal to 180 minus theta. So 180 minus our theta is 30 degrees, equals to 150. So our 2 solutions are 30 and 150. And then now let's go to where sine is equal to a negative angle. So same steps, shift sine of negative 0.5 is equal to negative 30 degrees. And now we are looking for the quadrants where sine is negative. Those quadrants, and we also have to remember that we have a restriction. We are restricted. Our restriction says x is only between 0 and 270. So it means x can be found in these three quadrants. We don't go above 270. So what we are going to do is that we'll look where is sine positive. I mean negative. It's positive here, it's positive here, it's negative here. So our solution is here. And if we didn't have the restriction, or if our restriction was between 0 and 360, we're going to have two solutions because sine is negative here and here. But because our restriction says x is between 0 degrees and 270, we cannot go above. So we only have, between these three quadrants, it's only this one where sine is negative. So we have only one solution for this one. So our x is going to be 180. This is the condition in the third quadrant. 180 degrees plus 30 degrees. And this will be equal to 210. So that is how the negative sign affects our x, and that is how our restrictions affect our x. So now let's go to another simple, and remember all of these things apply to all of the trig ratios. Whether it's cos, sine, or tan, you use these same steps to find your x. In all trigonometric equations, you use these same steps. These are the basics. These are very simple trig equations. So let's go to where we are given something like, they say our restriction is 0 and 360 degrees. So x is between 0 and 360. So what we are going to do, x plus 30 degrees is equal to 0.5. Let's add f5. So if we are given something like this and we are told to solve for x, we are given the restriction. We are going to apply the same steps that we did with these other equations. And what did we do? We had to make sure that x is on one side of the equal sign because we are solving for x. And so, same thing here. What we are going to do is that we first have to remove this 5. So we'll just say divide by 5 on both sides, and then we're left with 10. X plus 30 degrees is equal to 0.5 over 5. I prefer not to find the answer for this because I am looking for the most accurate answer, because if you find the answer for this and then you round it off, the answer will not be as accurate. And then to remove this tan from this side so that we are only left with this, we are going to say shift tan. just like we did before. So here we'll be left with x plus 30, and this will be shift tan of this 0.5 over 5. And then here it's now simple. We're just going to say minus 30 minus 30. So our x will be equal to shift tan of 0.5 over 5 minus 30 degrees. And so you punch this in your calculator, and our answer is going to be negative 24.29. Now our tan is negative, and remember, this is not the solution. This is not the solution, it's only our reference angle. It's our theta, this one. So what do we have to do? We have to go back to our cast diagram and look for the quadrant where sine is, what are we working with? We are working with tan. So we are going to look for our quadrant where tan is negative. And it's not here because all trig ratios are positive. This is where only sine is positive, so it's here. This is one of our solutions. And then here it's where only tan is positive, so it won't be this one because tan is positive. And here only cos is positive, so our tan is negative. So it's these two quadrants, quadrant number 2 and quadrant number 4. And remember, our answers must fall within the restriction. You see, we're given x is between 0 and 360, and these two quadrants are within 0 and 360, so we can use them both. So here, the first one, the first quadrant where our x is, there's a restriction which says x is, our angle is 180 degrees minus theta. So we are going to apply that condition so that we can find our x. Remember, this negative does not change the size of the reference angle, but what it does is that it changes the quadrants where we will look for our angle. So, as I said, the condition is 180 degrees minus theta, and our theta is this 24.29. 180 degrees minus 24.29 degrees. And our answer is going to, it's 155.71. And our second solution, we'll find it by applying this condition, 360 minus theta. So it's equal to 360 minus 24.29 degrees, and this will give us 335.71 degrees. So these are our two solutions. These are our two solutions. And then let's do another one with cos. If we are given a restriction that x is between 270 degrees and 0. So let's say we are given 10 cos x plus 5 is equal to 2. Yeah, let's say it's equal to 2. to do this, to find x, we are going to use the same steps as before. We have to make sure that x is on one side of the equal sign. So we'll do that by saying 10 cos x is equal to, take 5 and put it on the other side, negative 3. And then we just divide by 10, and then our cos x is equal to negative 3 over 10. To be left with only x here, we say shift cos, and it will be cos negative 3 over 10. And our answer is going to be, so our answer is 107,46. 107,46 degrees. This is not our final solution. This is the reference angle. So to find the solution, x is equal to, we look at the restriction. Our restriction is x is between 0 and 270. So we go back to the cast diagram. We are looking here from 0 to 270. We are not going any further. And so because when you put this in the calculator, it gives us a positive. You see? So we are going to go to where cos is positive. Where is our cos positive? It's in the first quadrant and in the fourth quadrant, but our restriction tells us that our solution can only be between 0 and 270. So this one, we will not be counting it. It will not be part of our solution. So our only solution is here. So this is in the first quadrant, but our angle is greater than 90 degrees. Do you see? Our angle is greater than 90 degrees, so it's not an acute angle. Meaning our solution for this, we have to apply the condition now. And our condition is 90 degrees minus theta, which is 107,46. And our x is going to be negative 17,46. 46 degrees. You see? So it's important to look at the sign of the reference angle. As you can see here, when we did our calculations, we were left with shift of cos of a negative number. But once we put that in the calculator, our reference angle is positive. So we have to work with the sign of this positive angle. And this positive angle and the restriction led us to this quadrant. And in this quadrant, we had to apply the condition because now our reference angle was not an acute angle, but it was positive. So we had to apply the condition of this quadrant, which is 90 degrees minus theta. And so this is what we did, 90 degrees minus theta. And then our final angle is negative 17,46. So that is how you can apply the cast diagram in your simple trig equations. It's important to note that you must always check for the limit or the restriction, always check your restriction and always check the sign of your reference angle, the sign of the reference angle, because it is the one that will tell you in which quadrant to look for your angle, and that will affect your final answer, your final solution. So that's all for the application of the cast diagram in your simple trig equations.